Hi, we've been receiving some awesome training from Animesh Singh. So he works for the Center for Open Source Data and AI Technologies in San Francisco as well. And he volunteered to give us a training at 11 p.m. on Sunday. So we received it here in Switzerland at 8 a.m. Monday morning. So thanks a lot for that. And I just want to share a part of this training with you because it covers a lot about the AI pipelines we are building on open source, and especially the stuff regarding fairness and robustness against adversarial attacks. So please enjoy.
We are the second largest contributor in Spark. We are the fourth largest contributor in TensorFlow, right? And of late, in Qflow, we are the second largest contributor over the course of last year. So some of the highlights, we talk about. And then typically, both of these talks, I sort of lead through from an AI workflow perspective that, the four stages are that, you have the prepared and analyzed data, then you have that initial model, assign hyperparameters, and then you train it. You got the trained model. After you validate and deploy, validate the trained model, you deploy it, and finally you have the deployed model, and then you run, the whole monitoring and analysis on top of it. Now, typically, many tools are available to build these initial models. Jupyter is an ecosystem in which we are heavily participating. IBM is, contributing a lot to Jupyter. Our studio and others are also, something which we consume in our products as well as, more contribute back. Then on the machine learning and deep learning side, right, many libraries we are contributing to TensorFlow and PyTorch. Of late, we have started, working with the community on the scikit-learn side. And since, there were many projects, right, we launched in open source something called Fiddle, Fabric for Deep Learning, which essentially, allows you to create a consistent experience on top of these, various libraries. And Fiddle actually, won an InfoWorld Award last year for Best of Open Source Software. And we are not doing it alone. We are actually doing it with community partners. So Fiddle is focused on training, right? We partnered with Selden for model serving. We got H2O.ai working under the covers so as to make sure, machine learning algorithms are available. With Uber, we actually work together to integrate Uber's forward mechanism, which allows you to do distributed training over distributed GPUs, either in a single machine or across multiple machines. And we worked very closely with Facebook to actually launch, PyTorch 1.0 on the same day PyTorch 1.0 was released by Facebook. And then there are platforms to serve your models, right? Create your model catalog. So we partnered with Selden, as I mentioned, right, to serve for model serving. We launched Model Asset Exchange in open source, to create that model catalog. But then, what about the trust factor in AI, right? Can your data set be trusted? Can your trained model be trusted? Once your model is deployed and giving predictions, right, are they fair and unbiased? Now, when we look at trust, we look at it around, these different areas, whether it's the model is, giving fair predictions, is it easy to understand? Can anybody tamper with your model? And is it accountable? So essentially, trusted AI for us in IBM goes for these four pillars, which essentially is, fairness, explainability, robustness, and assurance. Let's talk about robustness very briefly. Is the model vulnerable to adversarial attacks? For that, we launched a tool in open source called Adversarial Robustness Toolbox, or in short, ART. Right, it's a library dedicated to adversarial machine learning. Its purpose is to allow rapid crafting and analysis of, attack and defense mechanisms, and it provides, state-of-the-art implementation of many of the research methods available for, being able to simulate attacks on your models, being able to generate adversarial samples, and not only that, being able to defend your models, right, from adversarial attacks if they are found vulnerable. And these are, some of the attack and defense methods, which are listed. If you need to know more details, right, we have separate talks on this, right? We can point to more detailed slides where we actually, can explain. Plus, it's available on GitHub, so you can go and read. And you can see a very quick demo of art at this particular URL in terms of, what it actually allows you to do. Essentially, you can simulate an attack. For example, in this case, if you see an image, right, where the model is 92% confident that it's a Siamese cat, and if we generate adversarial noise and, contaminate this image, it's undetectable to human eye. But, as you see that, when we increase the strength of that attack, the model now predicts it's an ambulance, right, with very low confidence, right? So it actually got it wrong. So then what you can do is, you can use, many of the defense mechanisms available there, right? So for example, something like spatial smoothing, which is, think of it as like, blurring your image so you are not exposing so many pixels, right? So reducing the surface area of attack, sort of smoothing your image. For those of us, who do photo editing, we do a lot. In that case, once we implement that defense mechanisms, right, the model is again back to 94% confidence that it's a cat. Now that we have checked for robustness, right, how do we actually check for bias throughout AI life cycle, right? So as I mentioned, right, the bias detection can be done at various levels at the data set, as your trained model, for your deployed model. And ideally, right, I mean, the Wikipedia definition says that, it's a systematic pattern of deviation from a norm or a rationality in judgment. Now, if you look at examples of cognitive bias in machine learning, right, there was a big news in February 2018, right, where they actually compared, various vendors on face recognition software, and they found out that, there is an error rate of around 0.8% for light-skinned men. But when you actually, point images of dark-skinned women to the models, right, the error rate goes to as high as 34.7. So the two factors where you see, the model is being unbiased is once is, based on your race, as well as, based on the sex, right? And if you see, I mean, it's consistent throughout all the vendors. IBM, in fact, had the largest gap in that particular case, right? This is something, we have made sure we are addressing on our end at a very, rapid pace. The other aspect where, essentially, there was an article in October 25, 2017, where a Google sentiment analysis service, right, if you found that, it determines to the degree to which a sentence expressed a negative or positive sentiment. And for something like, Sikh, which is a religion in, mostly followed in India, but, across the world as well, and Christian, right, it was all good. But when it actually came to Jew, right, you see that, the sentiment expressed is being negative. Again, I mean, Google had to apologize for this particular service. They actually made sure, they are doing course corrections at their end. But this is, again, an example. Now, if you look at, something which happened with Microsoft in March of 2016, right, where they actually launched a bot, right? Unfortunately, within the first 24 hours of coming online, the bot actually became aware of coordinated effort by some users to abuse, and then it started, abusing back, right? So they had to take that particular bot offline, right, and make corrections, right? So as we see, even the major providers, the large tech giants, we are all, susceptible to this, right? There was a study published in ProPublica, right, where they actually, looked at bias in the criminal defendant justice system. Now, this is of significance because, the software has been used by judges over the years to actually detect and actually assist judges in giving sentences, right? So they actually used to inform judges, about who can be set free, or, who should be, further given punishment. Now, if you look at, what the software was doing, it was giving very, very, biased results. Almost in a lot of cases, white defendants were, mislabeled as low risk as compared to the black defendants. Some of the examples, if you see here, in this case, Brisha Borden, right? She was rated high risk for future crime, and they actually, took a kid's bike and scooter that was sitting outside. But according to the software, she was rated as very likelihood of redoing, something major again. But what actually happened was, after the fact that she did nothing, but Vernon, who was actually, uh, prior to this, had two armed robberies, one attempted armed robbery, actually did a grand theft, right? But he was rated low risk. And the same set of examples, actually abound into that, criminal justice defendant system software, right? In this case, if you see, Figurt was rated low risk after being arrested with drugs, right? And he was actually arrested three times on drug charges after that. On the other hand, right, Bernard, he was only resisting arrest without violence, but he was given as a sentence that he's more likely to reoffend, but he actually did nothing after the fact, right? In this case, if you see Mallory Williams, right, she was actually rated medium risk with a high number of six, and Greg was rated low risk with one. And Lugo actually has crashed his car into a Toyota Camry while drunk, right? So this is a case of DUI, and Mallory actually was rated as high risk. Now, if you see, she only had two misdemeanors, and after that she did nothing. But actually, Lugo actually went and was arrested for a domestic violence, right? So as you can see, these softwares, are being used to determine where do you get admission for your kids, where do you get job offers from, whether you get a subsequent criminal sentence, right? So the responsibility is huge, but the results they're giving, you know, can be so biased that it's hard to trust them, right? Now, if we look at the brief history of fairness in AI and ML, right, I think it was not until 2017, people actually said, yes, oh man, I mean, this really matters, and we should be looking into it, right? And machine learning, by its very nature, is always, a form of statistical discrimination. It does become objectionable when it places, certain privileged group sets an advantage, right? And in certain context, right, for example, it's illegal to actually give a result based on a person's race, gender, or age, within the United States of America, for example, right, and in many other countries, right. So now when we look at fairness, there are 21 definitions, and it only doesn't come from the training data, right? It can be introduced with inappropriate data handling, as a result of inappropriate model selection, incorrect algorithm design. So that's why we need a very comprehensive bias pipeline, and for that, IBM launched AI Fairness 360. It's essentially a Python toolkit available in open source on the URL listed away, and it has around 70 plus metrics on which bias can be detected, and around 10 algorithms to mitigate those bias, right? And as we mentioned, right, it actually can, detect bias throughout the AI lifecycle at different levels. We have different terms to describe it. Pre-processing means, before you actually get to the trained model. In processing means in processing algorithm when the model is, being trained. Post-processing means, once you have deployed your model is ready. In fact, once you trained your model and your model is ready, right? So in all these different phases, we have algorithms and metrics to detect bias. There are around 70 plus metrics, and they are all available on the website, which I mentioned before, ai360.mybluemix.net. You can go and read about them, the mathematical definitions behind them, right? And a lot of these metrics are essentially, focused on the aspects of, either it's fair for a group or it's fair for an individual, right? So they take into account, different characteristics. And it also works around, different notions of what is a false positive and a false negative. For example, in some cases, a protected attribute, and when we say a protected attribute, like a gender is a female or a race is a black, they might get, negative results, but those negative results are actually based on real things. Based on, for example, if their financial data is real bad, right, they are not going to get a loan approved. So in that case, it has nothing to do with their gender, or race. But so that's why we call them, a false positive in that case, right? Uh, but in a lot of cases, right, it's just because of their particular gender or race, they might get a loan denied, right? So those are, the real cases we want to account for, right? So there are different algorithms, as I mentioned, right? So something like disparate impact, which is essentially, you take the unprivileged group and the privileged group, right? The favorable outcomes they are getting, and you divide. That's when you get that ratio. If you subtract these two different things, that's what is called statistical parity difference. And then, you can actually take, you can remove the negatives, the false negatives and the false positives, and just take the real samples and then take a ratio or a negative value of a difference of them. Then it is called equal opportunity difference. So, there are many detailed explanations of these algorithms and metrics in the website there, right? And as we mentioned, right, in the machine learning pipeline, we actually work at every different layer. The 10 algorithms which we have, which can actually, help you mitigate bias, right? Or, things like optimized pre-processing, reweighing, adversarial debiasing. And if you want to, use it, it's actually available at aifn360.myblumix.net. There are prepared notebooks with that. Uh, and then, for demo, right, for example, we talked about the ProPublica recidivism database, right? So essentially, as I was talking, right, it actually is a software being used in criminal systems to, you know, and was being used to actually, award sentences, right? So there was a big article published on this particular topic where how it was doing, wrong judgments, giving wrong judgments. So for this particular, software, we can actually point AIFNF360 to that particular data set. And then it checks for bias metrics across two attributes. One is, the sex as well as the gender. So we call them, protected attributes. So in this case, the privileged group is a female, unprivileged group is male. That means, in all probability, males are going to be discriminated against. And it did actually go and found bias. What you see is, wherever you see this light pink mark, that means, it's further away from zero in the negative sense. So the further away from zero you are, you get classified as a bias, right? Typically the threshold is if it is more than 0.5, definitely, it's giving biased results. And in 4 out of the 5 metrics here, you see it's giving biased results for male. And the same for race. In this case, the privileged group is a Caucasian, unprivileged group is not Caucasian. And, in 4 out of 5 metrics, right, it's giving, again, a biased result. So now that, AIFNS 360 has detected there is bias in this, right, we can actually go and choose one of the, algorithms here to actually do, bias mitigation, reweighing, which essentially, with examples in each group and label combination differently to ensure, there is a fairness before classification, right? So it actually balances the data set properly, right? And there are different algorithms to actually handle it, which select reweighing in this case, for example. And then it's, reducing the bias in the training data sets, reweighing it. And finally, what we see is, it has actually brought down the bias to very acceptable levels, which is, 0.03, 0.02, and the same in the case of race, right? So that's essentially right, and these are, just a screenshot of what it does. And then, there are other open source projects, right, which are essentially working at different levels. AIFNS 360 is the only one, right, which has bias detection at every phase of the AI lifecycle, as we mentioned, right, pre-processing, in-processing, and post-processing. And not only that, it's not only detecting, it's actually giving you algorithms to mitigate bias, right? So with that, this is the open source ecosystem around which we are operating. And if you look at, the logical architecture, um, essentially how these things, work together around different phases of the life cycle. We actually, are looking at, ways to create, overall AI pipelines, combining them and creating these, targeting AI developers and data scientists so that it looks like, sequence of Python functions. So you can create, end-to-end pipelines with fairness and robustness included in them. So as you are doing the training, for example, using Fabric for deep learning, right after the fact, that you can use, robustness check and fairness check using ART and AI Fairness 360. And based on, if one of the tests is not passing, you can actually, retrain and rerun that whole pipeline after taking corrections.